Good day everyone, I'm Sumatra from Group05. We start off with the background of the selected process to produce synthetic kerosene, which is fission troops. It was a process originally developed from Germany in 1913. In 1923, chemists Franz Fischer and Ernst Rose wanted to test an indirect pathway to liquefy coal, whereby the solid coal will be turned into the gas. This process involves metal catalyst at high temperature, which is at 150 to 300 degrees Celsius, undergo various chemical reactions to actually produce the liquid hydrocarbons. I will explain the operation of fission troop process, but before that, what is synthetic kerosene? Synthetic kerosene is made up of hydrocarbons, same as conventional one, but a bit of tweak whereby it is an artificial kerosene that is made out of carbon and hydrogen atoms. Carbon usually be captured from the natural atmosphere or industrial plant. The hydrogen will undergo electrolysis and its source is renewable energy such as surplus of wind. Both this carbon and hydrogen will undergo fission troop synthesis to produce synthetic kerosene. The operation are such: the synthetic gas syngas being generated, then the synthetic crude being generated through fission troop synthesis, followed by this process whereby the synthetic crude being refined to the final product, which is synthetic kerosene.
This is the process for the PFD for the production of synthetic kerosene. It uses the fission trough synthesis. The production of synthetic kerosene is divided into three main processes: 1. Syngas generation, 2. Syncrude generation, and 3. Separation, upgrading, and refining. Energy from renewable electrical energy is provided to electrolyzer. Hydrogen will be transferred into RWGS reactor and react with carbon dioxide. The reaction will be conducted at high temperature above 800 degrees Celsius and form syngas. Syngas produced from previous process is streamed into flash drum. Syngas then passed through heat exchanger and mixed with internal gas recycle before entering fission trough FT reactor. A cobalt-based catalyst in FT reactor create a bond between the molecules to form paraffins, a main product. The byproduct of this reaction is a mixture of gases syncrude and unreacted syngas. The byproduct produced from upper stream of FT reactor get upgraded or refined. For the discharge of liquid hydrocarbon, all streams from a few flash drum will combine and flow through heat exchanger and produce synthetic kerosene. Lower stream of FT reactor is where a main product will form, which is liquid syncrude that is mixed with hydrogen in hydrocracker at around 360 degrees Celsius. Hydrocracking is conducted to crack heavy long chain hydrocarbons into lighter short chain. The hydrocracker product will then go through heat exchanger, entering flash drum and form final product, which is synthetic kerosene. This is the reaction scheme for the production of synthetic kerosene. This is the process parameters throughout synthetic kerosene production.
Now, let me move on to the appropriate design for the main reactor and explanation of the process in the reactor. In this production of synthetic kerosene, the multi-tubular feedback reactor is used to help the reaction between the syngas and the catalyst. Water surrounds the tube and regulates the temperature by settling the pressure of evaporation. It will leave the reactor in the form of steam. Then, the catalyst is fed continuously in a multi-tubular channel to maintain steady temperatures and high rate of catalyst activity and life. Next, the syngas, which are carbon monoxide and hydrogen, are fed into the reactor. The syngas will react with the catalyst producing the synthetic kerosene.